What's up everyone? How are ya? Welcome to my channel. It's me Tanishka back again, and today we're gonna talk about none other than the history of the development of the structure of the atom. But let's not complicate it. The atomic theory. Well, take a good look around you, and by that I mean a very good look. Take notice of all the things around you, including the very device you're watching this video on. What is it made of? You might say the cover is made of plastic or metal or whatever, and the device itself is made from, I don't know, say the circuit board is made of a combination of various different conductive elements. But what is at the very core of the elements that keeps everything together? Well, we're gonna learn exactly that today. Nowadays, we know that atoms have three subatomic particles, which are the protons, neutrons, and the electrons. But we didn't always know that until recently. In fact, atom models keep changing every so often due to advancements in technology and our understanding of the scientific world. Why are you waiting? Let's go! First up is the Greek philosopher Democritus. Democritus was a philosopher from, as I mentioned earlier, ancient Greece, and he had an abstract idea of what atoms were. Not a fixed idea. He was like, all things around us were made of one substance. For example, all humans were made of only human atoms, and all cheese was made of only cheese atoms. Well, that idea is not so correct according to today's scientific theory, but it was accepted at the time. So let's move on and see what the other scientists thought. Then, a few thousand years after Democritus came the British scientist John Dalton. In the year 1810, he proposed the billiard ball model, which stated that all atoms were like small billiard balls. Of course, now in the present, we know that atoms have a complex interior structure with subatomic particles, but at that time, he didn't know that, and it was a significant achievement. After studying the atom, Dalton concluded that all atoms of one particular element are the same. For example, if you take a carbon atom, all the atoms of carbon element are the same. And most importantly, atoms cannot be created or destroyed. Fast forward a few years after Dalton, in 1897, a British scientist, yet again named J.J. Thomson, discovered the plum pudding model, which dictated that an atom looked like a plum pudding. Let's learn more about it with the help of a picture. Here is a picture of the plum pudding model. As you can see, the picture is not mine. It is from Google. So the orange region which you see is the spherical cloud of positive charge, and the blue regions which you see are the regions of negative charge, which are the electrons. But at that time, J.J. Thomson did not call them electrons. He called them corpuscles. So basically, this model states that the negatively charged particles are embedded in a sphere of positive charge. Then, in the year 1911, came a New Zealand-born British physicist named Ernest Rutherford. Ernest Rutherford discovered the protons, or the positively charged particles in the atom, and conducted the famous gold foil experiment. Moreover, he also won a Nobel Prize and shaped modern physics. This is what Rutherford's model of the atom looked like. As you can see, a nucleus of positively charged particles was in the center, and all the negatively charged particles, or the electrons, were circling around it. Then, from his experiments, Rutherford concluded that atoms are mostly, or should I say, 99.99% empty space and have a nucleus which is of positive charge. Then, just 2 years later, a Danish physicist named Niels Bohr developed an atom model which helped us understand the bonding between atoms more efficiently. This model is still used to teach the different structures of atoms and the different bonding of atoms in schools today. This is a Bohr model of aluminium, As you can see, the nucleus is at the center and all the electrons are going around it in circular orbitals. These electrons can jump from one orbital to another, thus helping in bonding. Then, of course, a few years later, in 1926, an Austrian physicist named Erwin Schrödinger discovered the quantum orbital model of the atom and could predict the location of an electron in any point in time. In this model, the electrons move around the nucleus in clouds and not in circular paths like orbits. Not much progress took place in the field of discovering the structure of the atom until 1932, when James Chadwick discovered the neutron. Of course, the neutron is a very important subatomic particle, as I've told in the previous video, which you can go check out. Phew, we've covered a lot of science today. Hope you enjoyed. But you might be thinking, are we done yet? No, we are not. Because every day our knowledge of the scientific world keeps on increasing, and so does our technology get better and better. Sometime in the future, our world may know the atoms as something different. Who knows? Let's wait and find out. Another day. Thanks for watching. And if you enjoyed, please do like and subscribe. I'll be uploading more content on this channel in the future regarding science and various other topics that would interest you. If you want to ask something, say something, or request a new topic for our videos, you can do so in the comment section of this video, or you can email me, as my email is given in the description box of all the videos that I upload. Thanks for watching once again, and goodbye!